This is not this, but right off the bat, this is not the same of what we've been doing, where I just fill out the table and I'm good to go. Before I get into it, though, real quick, let's go. R equals 3. What's that going to be a graph of? Good. R equals -2 sine theta. Still going to be a circle. All right, still going to be a circle, probably on the y-axis on the bottom because it's negative. All right, so circle, circle. It's a heart. Yep, it'll be a heart. Yep, cardioid. Yep, on the x-axis probably. And then what if those numbers are different? Circle within a circle, lima sign, but circle within a circle. So those are the 4 graphs we have. Just look at the equation you're going to do on this first problem. Does that match anything we've gone over?
Well,
kind of, right? But now, and this makes a big difference, you're going to see a number next to the theta. That makes a huge difference, all right? Because it is not going to be anything close to a circle. Okay? In fact, how I want to start this day off is take a look at what it's going to look like. Graph this sucker for me. All right, so you can take a look and I can put a name to this now. When I put a number next to the theta, make sure you're in radian mode too eventually. So go to Grapher, type that equation in, R equals 4 sine 2 theta.
Oh, that's pretty. I like that. It's really annoying, but...
Everyone getting this on their graphing calculator.
What would you call that?
Oh, I got a name for it. It's got an official name.
Let me guess.
No, you won't be able.
Does it have quad?
No. Because might be 3 of these, might be 5, might be 6 of these. These, by the way, so we can start talking some math, these are called petals. Okay, they're called petals because what you guys have is when I put a number in front of theta, these are called rose curves.
Rose is like the last.
I don't know what to tell you. Rose curves. All right, again, got to be able to recognize that because what I'm going to show you today is a little bit different. Table is no use to us. All right, table is no use to us. So you have to have the ability to identify, I see a number in front of theta. This is going to be a rose curve. So I need to approach it differently than what we did the last couple of days, was just type, plot, plot, plot. Okay? The table will not help us. And the reason is, and I won't go into a 10-minute explanation why, but the table, if you filled out the table and started graphing the points, you'd be like, how in the world does that look like what's on my graph? It wouldn't. So I need a different technique to show you. There are 3 things you need to find before you graph these rose curves. 3 things you need to find. Number 1, how many petals? How many petals? Yeah, I know, because you're on there's 4. But how do I look at the graph and know that? How do I look at the equation and know that? And everyone's going to say, I know, just look at the first number, but that's not the answer. The answer is the number next to theta. Is it even? If it's even, you have double the number of petals. Let me say that again. If that number next to theta is even, which it is, you will have double the number of petals. So that's the first thing you want to find out. If it's odd, I'll tell you what happens in the next problem. So determine how many petals you have. Everyone okay on how to determine that? Double. And I'll be honest with you guys, I'm probably not going over 4 with you. All right, we're not going to get nuts and go to 8 or 10. All right, we're going to stick probably right with 4 or 2. All right, next. Second thing, I said there was 3 things you got to figure out before you graph. How far apart are the petals? Because if you saw on your graph, these are a certain amount away from each other. Okay, certain amount of degrees. So how far apart are the petals? I'll get to that next problem. I'll get to it. It'll be odd in the next problem, and I'll talk about how many petals there are. So how far apart they are. They need to be spaced evenly around your grid. The grid goes all the way around to what? Yeah, 360. And you're trying to place how many petals evenly spaced? So that tells you each petal will be, in this case, in this problem, 90 degrees apart. Okay, 90 degrees. So if you look back at your calculator, these petals are 90 degrees apart. Just stay with me and I'll show you how to graph. Last thing you need to figure out. Where do I start? Now, what radian, what degree measure do I start at? Okay, where do I start? And if you look at your graph, I just heard it from, we're not starting at 0. Look at this first petal. First petal's right here. How can I tell where this is here? All right, it is 45. Now, how do I get there? All sine rose curves. All sine rose curves. And let me say this very slowly and a couple times. All sine curves start halfway between how far apart they are. Let me say that again. All sine curves start halfway from however far apart. Now, they were 90 degrees apart, right? So I take your 90, however far apart they are, and divide by 2. So that tells me my first petal will start at 45 degrees. My first petal will start at 45. So these are the 3 questions you need to write down and answer before you start graphing, because I am not using a table. Okay, watch how quick this goes now when I don't need the table and I just have these 3 things. All right, so we're going to start at 45 degrees. If you don't know what that is in radians, I don't care, because you know it goes by how many degrees again? Anybody remember? Each goes by 15. Find where 45 is, please. Find where 45 is, because that's where the first petal is going to start. So 15, 30, boom, pi over 4, right? Okay, so the first point we're going to plot is how big that petal is. And you can always tell how big the petal is because we've learned this with the circle. It's whatever that number out in front is. So our first point we're going to graph at 45 degrees is 4. 1, 2, 3, 4. Here's where our first petal is going to start. 45 degrees at 4. Questions on that point? Because I'm going to go a little different now. All right, next. How wide or how narrow is this petal? All right, I don't want this. Oh, I'm going to do that. I want to be a little exact. I don't know how wide or how big it is. So here's what you're going to do to figure that out. You are going to plug in the radians on the left and the right of where you just plotted that petal. So ready? To the left is pi over 3. Do what you've been doing the last 2 days, kids. Plug it in for me. All right, so test the one to the left and test the one to the right. So plug in pi over 3 for me and let me know what value you get. You got 1 day left there, 2 chains. 1 day left. Come on, you can suck it up. What do you guys get when you plug in pi over 3? 3.5, about 3.5 or exactly 3.5? About 3.5. So ready? At pi over 3, you go 3, 1, 2, 3.5. And now do the one to the right here, pi over 6. And watch how quick this is going to go. And what do you get for pi over 6?
2.
2.
Isn't it the same thing?
Who's getting 2?
Is it the same thing?
It should be 3.5.
Yeah, I told you.
Pi over 6. 4 times sine, 2 times pi over 6.
We make our shape.
Now you can see how wide or how narrow it's going to be, right? And make sure you starts at the pole too. So there's petal number 1. And now because we answered these questions ahead of time, now this should go pretty quickly. I'm not going to go quickly, but hopefully it goes quickly now. There's petal number 1. How far apart are they again? So I can go to petal number 2. How far apart are these petals again? 90 degrees. And remember, it goes by 15 degrees every time. So at pi over 4, ready? That was what? 40. That was, okay, so we go 15, 30, 45, oh boy, 60, 75. Oh, here's where pedal 2 is going to start, right there at 3 pi over 4. I go every 90 degrees. And what's that point going to be again? How far out does the pedal go? To 4. 1, 2, 3, 4 at 90. And you can type it in your calculator, the left and the right now. But guess what's going to happen?
It's gonna be the same.
It's going to be 3.5 again. All right, you can test it out on your own, but it's going to be 3.5 again. To the left and to the right. And now we go another 90, right? We go another 90. So see where you'll go by 15s, remember? Count off by 15s to figure out where this next one's going to start. So 15, 30, 45, 60. 5 pi over 4. Is that where I land 90 degrees later from where I started? Make sure you go from where you started, not the right and the left part, from where you started. 1, 2, 3, 4. And then to the right and the left will be 3.5 again.
You-
Do we have to fill out the whole table every time?
Not for rose curves, no. But for any of the other ones we've done, yes, but not for a rose curve. I don't think it's helpful if you guys do anyway. It's more confusing. It's a beaut. And pretty much looks like our one we had in there. All right, blown up a little bit. I don't want to leave this. Anything you want to ask here? Because this next one's a whole different set of rules. Again, even, double it to find how many pedals you have. Always divide by 360 with how far apart they are. And a sine curve only will start at halfway between how far apart they are. Are you ready to go to the next beast? Questions? Graph it first. Maybe you can answer some of these questions. Graph it first. How many pedals you got? Think you know the rule now? We know what happens when it's even. What happens when it's odd? It's that number of pedals. Okay, so if it's an odd number next to the theta, if it's an odd number next to theta, like it is for 3 here, that's how many pedals you have. If it's even, you multiply by 2. All right, 2 doesn't matter what I put in front of you, how far apart they are. We still figure that out the same way no matter what we're talking about, which is 360 divided by the number of pedals. So how far apart these going to be? 120 degrees? And then the last thing, where do I start? Let me ask you this question to see if you're really picking this up. If this was a sine one, just like we did, if this was sine, where would I start?
At 4.
Where would I start?
Start at,
Where would I start this one if this was sine? 120 divided by halfway in between, right? halfway, so it would start at 60, right? If it was signed halfway between how far apart they are. Okay, but it's not. Look on your graph. Anybody see where it starts? Right at 0. Make this easy for you. If it's cosine, first pedal is always at 0. Okay, if it's cosine, first pedal always at 0 degrees. It's sine we got to do a little work for. Okay, so first pedal for a cosine curve is always at 0. You ready to go? So I'm at 0. How far out do I go? What? Number out in front, right? Tells you how long the pedal is. So, yeah. The 3 tells me there's 3 pedals. I'm going out to 4 again. Ooh, you ready to test the right and the? Ooh, I know it's not labeled for you. You guys been through this unit with me. What's it go by in radians? What's this one right here? Pi over.
Oh wait, the first one.
Just go 120.
0 to 37.
I know it's 0, but I got to test what's to the right and to the left so I can get a wide or narrow. I know it goes by 15 degrees, but you're plugging radians in the calculator, so it's pi over. Anybody remember? It goes by pi over 12. Yep. Yeah, right. You had to make it out of 12. Remember doing that? So there's the one to the left. What about the one to the right? Nice. 23 pi over 12. There you go. Plug it in. Make sure we're plugging it into the original equation. Pi over 12 and 23 pi over 12. So I can see how wide or narrow this sucker is.
$2.8.
2.8. Looking good. 2.8, everyone? Yeah, 2.8. I believe that is it. Yep, 2.8. And that hopefully that's the last time you have to do it. 12.8. 12.8. Okay, now we're not going 90, we're going 120. So multiples of 15, right? Multiples of 15 from 0. Figure out where my next pedal has to be. Yep, should be at 2 pi over 3. And if you forget that 2.8, again, just do the radians to the left and the right, but it always will be the same all the way around. And another 120. Four pi over 3. And sad as it makes me say, that's a wrap.